So today we're looking at the Pythagorean theory, which is something you should have done in grade 7 and 8. We're looking for specifically an unknown side in a right angled triangle. This is super important. We have to be using right angled triangles when we are doing Pythagorean theory. We are going to learn other math in other years where we're working with non-right angle triangles, but in grade 9, right angle triangles, that's what has to happen. So Pythagoras was a Greek philosopher way back in the day. And because there weren't great history stuff, we don't know a lot about them. But what Pythagoras figured out is that there is a ratio, there is a comparison that you can make of the sides of a right angle triangle. So he found if you knew the lengths of two sides of a right angle triangle, you could find out the length of the third side, whether it was the hypotenuse or whether it was two of the legs. So here we've got a diagram. This was from Pythagoras's work, and you can see here's a right angle triangle, and he figured out that the sum of the squares, that's why there's like these squares drawn here, and we're going to look at that in the next slide. So Pythagoras' theory says that when you have a right angle triangle, if this is, I don't know how long this side is, but if I made a square of that side length, I just took this side and I drew it there, drew it there, drew it there, and made a square, the pieces that make up this square are actually the addition or the sum of the pieces that make up a square here. So this side was a 3. So 3 by 3 by 3 by 3, that's a 3 by 3 side. And if this side is a 4, so there'll be 4 sections on this side, it's a square of 16. So we've got our 9 square here, our 3 by 3, and our 4 square here, our 16, 4 by 4. 9 plus 16 gives you 25. And if you look, the square that was produced from this side is a 5 by 5, which is a 25 squared unit triangle. So this is what Pythagoras discovered when he was working with these right angle triangles and making relationships. And why this works, don't worry about it. You just have to know that it does work. So what does that mean for us? Let's find the length of an unknown side. So here is a triangle. If we were using Pythagoras's work, we would have gone, okay, well, let's make a side of 5. So let's extend it and make a square here. That's a 5 by 5 square. So there would be 25 pieces. Okay, and then there's 12. Let's measure out 12 down and make a 12 by 12 square here. Well, that's 144 pieces. So then this side length here would be 144 plus 25, which gives us 169, which means if we take the square root of that, we'd get a 13 side triangle. Now, nobody wants to take the time to count up all of those squares. Are you joking me? That is not what we're here to do. So there has to be a better way of doing this, and that's what Pythagoras figured out and came up with a nice equation for us. So we're going to look at that in the next video.